Hi guys, today we're going to move on from area and we're going to start looking at volume. So when we were thinking about area, we were thinking about a two-dimensional shape. So we only had to factor in the length and the width. So we were multiplying two things together to find the area. Okay, moving on to the volume, and the volume is the space contained within a three-dimensional object. So when we're thinking about volume, we are thinking about a three-dimensional shape, and therefore we need to multiply three factors together to find the space inside our three-dimensional shape. Okay, so we're going to look a little bit more at that. So when we are finding the volume of a shape with a uniform cross-section, remembering that a uniform cross-section is basically the same shape all the way along the prism. Okay, so this here would be an example of uniform cross-section. This here is our hexagonal prism, which is a uniform cross-section. Every time we slice along here, we would end up with that shape. Okay, so with our uniform cross-section three-dimensional shapes, we must find the area of the end and times it by the length or the height, depending on which way the object is sitting. Okay, so that's the principle we're going to start with, and we see we have a square-based prism here, so we're going to do the area of the end times the length. So we have 2 by 2 gives us the area of the end, times by the length will give us the total volume of the shape. This triangular prism here, we were lucky enough to be given the height, so we find the area of this end, which is half base times height of the triangle, times by the length of the solid to give us the overall volume. Now with a triangular prism, if you weren't given the height and you were given the side lengths, you would need to use Pythagoras to find the height before you could find the volume of that shape. So that's just something to keep in mind. With our cylindrical objects, uniform cross-section, we're going to find the area of the end times by the height. So we've got our pi r squared will give us the area of the top, and then we're going to multiply it by the height to give us 100.53 units cubed. Okay, moving on to some other objects that you'll need to find the volume of. Spherical shapes are our ball type shapes. So with, anything that's a ball shaped has the volume formula of 4/3 times pi r cubed. Okay, so this is just one of those formulas you just have to be comfortable working with. So into your calculators, I would normally put the fraction, set the fraction up for your 4/3, cursor along, and then you can enter your pi times the radius. Okay, now remembering that sometimes you will be given the diameter and you'll need to halve that to find your radius before you can use the formula. So keep an eye out for that one as well. To the power of 3 will give us 523.59. With a hemisphere or a semicircle, hemisphere is a preferred term, we're talking about half of a sphere. Okay, so half of a sphere is really just the sphere formula, and then we're going to divide that by 2 at the end. Okay, so no different there, just dividing by 2. You will also need to find the volume of some irregular uniform cross-section shapes, which means that it's got an awkward kind of end, but it's the same shape all along. So really we just need to be clever about how we find the area of the end, and then it's multiplying by the length. So for example, this one here, I would divide it into a large rectangular prism at the bottom and a square prism at the top. Okay, then I would find my area 1, my area 2, add them together, then we can times by the length. So area 1 would equal 3 by 3, which equals 9. Area 2, now if this is 3 and this is 3, this here is going to be 6. So our area 2 is going to be 3 times by 6, which equals 18. Okay, and I'm going to make this 10, just so that I don't need to get my calculator out. Cheeky. So 9 plus 8, so our total area, so our volume is going to be equal to A1 plus A2 So that would give us the total area of that end. Then we're going to multiply that by 10 to give us the volume. Okay, so 9 and 18 gives us 27. Times by 10 will give us 270 units cubed. Okay, so you're going to come across all different sorts of irregular shaped prisms, but if they're a uniform cross section, all you do, find the area of the end, times it by the volume. Okay, just a couple more shapes to go and then I'll let you get started. So I just want to quickly have a look at a pyramid. Okay, so if we have a square-based pyramid, which comes up to a point. Okay, pyramids or cones have the formula 1/3 of the area of the base times the height. So it's basically the same principle as finding a prism, but you're only wanting 1/3 of that, because when we have a pyramid, what you can see is that it's not a full prism. Okay, so it's in fact 1/3 of a prism. So we're going to find the volume as if it was a prism and then times it by 1/3. So if we had a 4 here and a 4 here, and once again we were lucky enough to be told that the height of this pyramid is 6. Okay, if you weren't told the height, you might need, or you will need to do some Pythagoras to determine the height using the side lengths and the diagonals of the base, but that's another lesson. Okay, so our volume is going to be 1/3 of the area of the base times the height. Okay, which in this is 6. Okay, so we've got 1/3 of 4 4s are 16. 16 times 6 gives us 96, and 1/3 of that is 32 units cubed. Okay, similarly, if we had a cone shaped, okay, our volume would equal 1/3 pi r squared times by the height. Okay, so we're just putting that 1/3 in at the front. All right, that's probably enough for you to get started. So work from sector and enjoy. Thank you. Bye.